question number 8 from the summer 2014 paper for Dynamical Systems and Chaos. Question 8a, we want to determine the Lyapunov exponents for a logistic map, and we also want to say what type of solution is defined for these Lyapunov exponents here. For 8b, we're given the MATLAB program for this Koch fractal, and we want to modify this program to give the MATLAB program for this fractal. So for A part A, we want to write a MATLAB program which is given in the notes. So in this case, mu is 3.5. We take x is 0.1 and we put x naught is x. We're going to iterate 50,000 times. So for n is 1 to the maximum number of iterations. Here is our iterative formula for the logistic map, and then here is the formula for the Lyapunov exponents, which is given up here. So the Lyapunov exponent is the VPA, is the variable precision arithmetic of the sum of the log of the absolute value of mu times 1 minus 2x, and you can see over the itermax, and we're doing to 6 decimal places, 6 significant figures. Notice that in MATLAB we have to do dot times and dot times here because x is a vector. So you may get a different mapping, so remember that x is a vector. And if we run this program for this value of mu, we get minus 0.872. When lambda is negative, it denotes stable behavior. Lambda equals 0 gives us a point of bifurcation, and if lambda is positive, then that denotes chaos. For part B, we need to edit certain lines here. So in your answer booklet, you only have to record the lines that have been edited. So you'll notice that in this case, we have 4 segments, but in this one we have 1, 2, 3, 4, 5, 6, 7, 8. So we need m max is going to be 8 to the k, because at each stage, each segment is replaced with 8 segments. Here the scaling, we've got h is 3 to the minus k, so this is 1/3. So these are each length 1/3, but you'll notice that these segments here are each length 1/4. So that's why we've got h equals 4 to the minus k, because each of these is a length 1/4, and the segments of the fractal decrease by 4 to the minus k. Now we've got to work out the angles. So here you got angle 1, angle 2, angle 3, angle 4. In this case, we're going to need 8 angles. And you can see the first angle is 0, then pi over 2, 0, minus pi over 2, minus pi over 2 again, and then 0, plus pi over 2, and 0. So those are the 8 angles. And then finally, we need to modify these 2 lines here because we've got 8 segments. So the segment B is mod M8, and the M is floor M over 8. So in your answer booklet, you need only write these lines, and you can see you get the appropriate marks there. So that concludes the solutions to question number 8.